Hello everybody, Gliderman here. So today we're going to be working on robot calibration, and this applies to basically the NXT and the EV3, so you can use whatever one that you're using to follow along. So what we're going to be doing is we're going to be clicking this little drop down here, and then we're going to go to Other for now. Then under LeJOS EV3, you would select LeJOS EV3 project. If you were using the NXT, you would use the standard LeJOS NXT project. I'm going to be programming with the EV3 here and then actually demoing on an NXT. So we're just going to click Next, and we're going to give it a project name. So we're just going to call this Robot Calibration, just like that. Make sure that your execution environment, JRE, is set to Java SE-1.7, and then you can click Finish. Once that loads, you can see that it appears over here. We're going to click the little drop down. You're going to see that we have our JRE, which is our Java runtime environment, and the LeJOS EV3 runtime. We're going to click on the source folder, and then we're going to click this little icon up there, which will create a package. We're just going to name it Pack for now, to hold all of our classes, which in this case we're only going to have one. And then we're going to click the New Java Class button. Now we're going to give this a name, and I'm just going to call it Robot Cali, just like that, for robot calibration. I'm going to check the public static void main string args, and then click Finish. So you're going to see it appears over here, and then automatically opens here. So the first thing that we're going to do is we're going to delete this comment, and we're going to instead create a new, just by typing new, robot Cali, and then open parentheses, close parentheses, and then a semicolon. So this will create a new robot Cali class. Remember, the main is our insertion point into the program. So we're now going to type down here public robot Cali, and then an open brace like that, and then enter or return. Now what we can do is we can start configuring our differential pilot that we're going to be using to control this robot. So up here we're going to make it a global variable. So I'm going to type differential pilot, and I'm just going to call it pilot. You're going to see that this pops up a little error saying that it can't be resolved, but that's simply because we don't have it imported. So we're just going to double click this option, and now it's imported up here. Down here, we're going to call pilot is assigned a new, not pilot, differential pilot, and then open parentheses. So this is very similar to what we have here, except in this case, we're actually assigning whatever this returns to this. So now what we need to do is we need to enter in the wheel diameter and the track width, and then the left motor and then the right motor. So I'm going to get back to the wheel diameter and the track width, so I'm just going to type 0.0 and then F, comma 0.0 F. So that's the wheel diameter and then the track width there. We'll get to that in just a moment. Now I know that the left motor is going to be motor C, and that the right motor is going to be motor B. So you can see it automatically imported the motor class there. And now basically what we're going to tell it to do is just go forward. So that's going to be pilot.travel, and then we're going to be measuring everything in centimeters. So we want it to travel a meter. So that's of course going to be 100 centimeters. We will not be adjusting this value. We will actually be adjusting the value in here to get the 1 meter travel. So we can save that, and we're going to jump over and we're going to look at our robot and measuring the wheel diameter. Okay, so this is the robot that we're going to be using here, Yes, I am using the NXT, but remember this is basically a universal thing for EV3s, NXTs, that kind of thing. Whatever's using LeJOS. So what we need to do is we need to measure the wheel diameter of these wheels here. And basically what this is a differential drive robot where one motor is controlling each wheel, and then there's a caster wheel in the back that's just swiveling wherever it needs to go. So we need the diameter from basically the top to the bottom. I've got my little ruler here. Let's see. Sorry, it's a little bit clear. So, let's see. We're just going to line that up there. And that looks to be about 55 millimeters or 5.5 centimeters, which is the unit that we're using. So, let's go and enter that in to the program. And real quick, you'll actually see right here, I don't know if the camera will pick this up, but there's little markings on the wheel already from LEGO that state the diameter of it. It's your option whether or not to trust that. I measured 55, this says 56. We'll see who's right. So, back over to programming. Okay, so I measured 5.5 centimeters for the wheel diameter. So right here with this first parameter here, we're just going to type 5.5. And then you would just save that. You can click this little floppy drive icon up there. Control S or Command S will also work. And now we're going to run that. So we're going to click this little drop down next to the run. And then we're going to click run as a LeJOS EV3 program. And this will upload to your Mindstorm's brick. So just click that and then it'll upload. So let's see how it runs. So what I've got is two pieces of tape, one here, one there, and they're 1 meter apart, and that's so that we can test and see if it went actually too far, too short, that kind of thing. So let's see how the program goes. So we're just going to hit that. Okay, so it looks like it went a little bit too short. So it looks like we need to decrease the wheel diameter that we're passing into LeJOS so that it thinks that it needs to spin the wheels more. Okay, so now we're back at the programming. I don't quite think that the 1 millimeter difference will actually make the big jump that we need. So let's try 5.25. So it's a little bit bigger than that. So let's save that, and then we just simply click the run button, and that'll run. So let's see how that goes. So now with 5.25 entered in as the track width, let's give it a whirl and see how it goes. Well, that looks like it actually went perfectly. So I think we can stick with that for our wheel diameter. So now with the wheel diameter entered in, we now need to figure out the track width so that it can turn a perfect circle, or 360 degrees. So what we're simply going to do is we're going to measure the distance between the center of the, in this case, right wheel, and the center of the left wheel. And so that looks to be about 112 millimeters, or 11.2 centimeters. So let's give that a shot. So the track width that we found by measuring was 111 millimeters, or 11.2 centimeters. So we're going to type 11.2 in here, and then we're going to change this from a travel command to a rotate command, and we're going to rotate it 360 degrees. So we're going to save that, and then we just run that to our robot. So let's give it a run. Okay, so it looks like that went slightly too far. I believe we'll need to turn down the track width for it to turn less. So let's give that a try. So let's try just turning it down to 11 centimeters. So we're just going to delete that and replace that with a 0. I'm going to save that, and then we just run that. So that looks pretty good. I think we'll just keep it at that. So that wraps up our calibration of this robot, and so you can do these exact same tactics to calibrate yours, as I did here, and you can get very accurate results with your robot. So thanks very much for watching, and I'll see you next time. Bye!